Hello. Now we're going to look at adding and subtracting our letters in algebra. And we're going to call the things that we are adding and subtracting terms. But we're going to come back to that language in a minute. We're going to start with a story. So imagine we're during a healthy living week in a school. Where we're focused on all the different ways that we can be healthy. And one of the things that they've decided to do in the school is that each class can order some fruit for lunch. So when the order is gathered up, we ask everybody in the class to write down what fruit they want, and the list that they get back is a little bit jumbled. So we have the list for the fruit order is 4 apples, 6 pears, 3 bananas, 5 apples, 2 bananas, a pear, and 3 apples. And what do we do with this? Well, we want to hand it off, and we want it to be a neat list to hand off to whoever is getting this fruit for us. So we don't want to leave it in this messy state. How can we figure out what the total order is? How much apples do we want in total? How much pears do we want in total? How much bananas do we want in total? So our job now is to write out mathematically, using our symbols, how we would describe the situation we've got and see if we can use our methods of algebra to simplify the problem so that we can get a neater order for our fruit for the class. So what would be a sensible letter to pick for apples? Well, A is a reasonably sensible letter for apples, P for pears, and B for bananas. So let's write out our list. We want to add up all of these things because we want to know our total amount of fruit. So 4 apples. Well, if we have 4 apples, we know that if we have a number sitting next to a letter, that means they're multiplied. So 4 apples we would write as 4A. A number sitting next to a letter means multiplied. So this would be A plus A plus A plus A would be 4 apples. If I have 1 apple, 2 apple, 3 apple, 4 apples added together, that would be 4 apples. So that's my situation there. I have 4 apples. And I want 6 pears. So that would be 6 pears plus 3 bananas plus 5 apples plus 2 bananas plus a pear. Well, how are we going to say a pear? We could write down 1 pear, but the shorthand way of doing it is just to write down P for a single pear. So you can write down 1 in front of your letter or to mean one of something, and that's fine. You won't lose any marks for it. But what you will see as we go forward is that this is an abbreviation. This is a shorthand way of saying I've got one of something. I just write down P for a pear. And then I have 3 apples. So that's all of my different bits of my shopping list of my order for my fruit. So I can see that I have 4 apples, and I have 5 apples, and I have 3 apples. So I'm going to want to know how many apples I've got in total, and I have 6 pears and 1 pear, and I have 3 bananas and 2 bananas. I think that's all of my different pieces got together. So I've put a different symbol underneath each one of my types of fruit, and that's going to make it easier for me to gather up all of the different types of fruit that I'm talking about. So I have 4 apples plus 5 apples plus 3 apples plus, now I'm going to deal with my pears, 6 pears plus 1 pear plus my 3 bananas plus my 2 bananas. I now have all of my same types of fruit gathered up. So it's easier for me now to see what my overall totals are going to be for each type of fruit that I've got. So I have 4 bananas and 5 bananas and 3, sorry, my apologies. We have 4 apples and 5 apples and 3 apples. In total, we are going to have 12 apples. So my order is for 12 apples, and I have 6 pears, and 1 pear is going to be a total of 7 pears. And then I have 3 bananas and 2 bananas is going to be a total of 5 bananas. Now that's as far as I can go with my order. I can't make it any simpler, because if I told the person that I wanted, what is that? 12 and 7 is 19, 24. If I told them that I wanted 24 apple pear bananas, that wouldn't help anything. The person would just look at me and say, hey, I can't do anything with that. So this is as far as we can go in terms of adding up our apples, our pears, and our bananas. It wouldn't make sense to add 12 apples to 7 pears. That doesn't mean anything physically. It wouldn't make sense. So we can only add up our apples together and our pears separately together and our bananas separately together. And then that's as far as we can go. We can't make it any simpler than that. So this is the order that we would be sending off to get our fruit for our class. Now, what we've done here in terms of a story, as I'm trying to explain to you here, leads into a very important idea. We can only add up what we call like terms. So the apples are a particular type of term. They have A in them. And the pears are a particular type of term. They have P in them. And the bananas are a particular type of term. They have only a B in them. So if I had the term 3x, so 3 of whatever x is, I would call that overall thing a term. So 4a is a term, or 3b is a term. The number in front of my letter is called a coefficient. So it's a number that's multiplied by my letter. And the letter itself is called a variable, because as time goes on, we are going to vary the value of x, or the value of a. So if we change this to being the cost of an apple, we might find that the cost of an apple was something in one shop and different in another shop. So a, or x, can vary, so we call it a variable. And we'll talk about that more shortly. So again, this overall block here of my coefficient multiplied by my variable is called a term. And we need to build up comfort with this language so that we can do more complex work as we go on. So that's our story example done. Now we're going to apply what we learned from our story to add up our different situations here and also do a little bit of multiply. So if I have a plus a plus a plus a, I know that that is going to add up to 4 a's. So I have, if I imagine this was apples, I have 1 apple plus 1 apple plus 1 apple plus 1 apple is in total 4 apples. So that means that I can write it down as 4a. Now, what happens if, like in our fruit example, we don't have all of the same letter? We have different letters going on. Well, then I'm going to do what I did in my fruit example. I'm going to put a different symbol underneath each type of thing, and I'm going to gather them up, 3 and a y. So let's gather up all of the different types of things. I have an x and a 2x and an 8x all added together. So I'm careful. I look at the symbol that's in front of my term and make sure that the symbol stays the same. And I have, oh, and I missed a y. So make sure you have a symbol underneath everything. And I have a plus 3. And I have y plus y. So I've now gathered up all of my different types of thing. And I've put a different symbol underneath each. And this trains me to be able to see the different types of symbols. This structure is very important. So I have 2x and 8x. So in total, then I'd have 10x plus 1x is 11x. So I know if I have x by itself, just like with my single pair here, this means I have 1x. So I could put a 1 in front of here, but we won't normally. So you won't find me doing it very often, but there's nothing wrong if you want to put a 1 there. So I have 1x plus 2x plus 8x. In total, I end up with 11 x's. I have 1x and 2 x's and 8 x's. So in total, I'd add that up to be 11 x's. Then I have plus 3, and then I have 1y plus 1y would be 2y's. Now, by convention, this is one of the things that we'll get used to over time. We write the letters in alphabetical order, and then we put the numbers on the end. And over time, we'll get more used to this. So the letters we write in alphabetical order, so X and then Y, and then if there was a Z, and then the numbers on the end. Now, let's practice this one. We have 2 multiplied by 3x plus 6y minus 3y. So we know from BIMDIS, if we have any sums that involve multiply and then add and subtract, we have to do the multiply first. And that's going to be true in algebra just as much as it was before. So we have 2 multiplied by 3x. Well, we know that 3x just means 3 multiplied by x. So now what we've really got is 2 multiplied by 3 multiplied by x. Well, I can't just write down 23x because that would mean 23x. But what I can do is multiply these two numbers together. So 2 by 3 is 6, and that's all multiplied by x. And then I have like terms here, and they're already grouped together. So I have 6y minus 3y. Well, that means I'm going to be left with 3y's. I had 6 of something, I took 3 of them away, so I'm left with 3 of them. And that's as far as I can go because I can't add my x's and my y's. Now here I have a similar situation. I have 4 multiplied by 8 multiplied by m. Well, I know I can just put the number sitting next to the letter for the multiply with m, but I have 4 multiplied by 8 is going to give me 32. And that's multiplied by m. So this means 4 by 8 is 32 multiplied by m. So this is the same as this. Now, building on our ideas of multiply, if I want to think about the area of some rectangles, if I had a rectangle with a length of 4 and a width of 3, I know that the area is equal to the length multiplied by the width. Well, that means the area would be equal to 4 multiplied by 3. So I put that in brackets. 4 multiplied by 3 is 12. Now, if we had algebra involved, we'd have a length of 2x plus, a length of 2x and a width of y. So we'd have 2x multiplied by y. Now, what am I able to do? Well, I'd multiply the numbers together. I know there's a 1 here in front of the y, so 1 by 2 is going to be 2, and x multiplied by y, well, all I can do is write down xy, because I know letters sitting next to numbers is going to mean multiply. So that is my job done. Letters sitting next to numbers is going to mean multiply. Letters sitting next to letters is going to mean multiply. You can actually see that in the way I've written the area formula here. So I wrote it out in English here. I've written it out more algebraically here. Capital A for area is equal to length multiplied by width. And I don't need to put in brackets because a letter sitting right next to a letter means multiply, just like a letter sitting next to a number means multiply. Finally, I have the perimeter of my triangle here, and I can see this is an isosceles triangle because this length is the same as this length. It's a plus 2 and a plus 2. So it's an isosceles triangle, just to link it in. And the perimeter is going to be, if I walk around all the edges of the shape, so the perimeter is going to be a plus 2 plus a plus 2, this length plus b minus 1. And I add up all my like terms. I have some numbers I can add up. Apologies. I have some numbers I can add up. And I have my b. So I have perimeter is equal to a plus 2 plus 2 minus 1 plus b. Perimeter is equal to 2a 4 and 3 plus b. And I know I write everything in order, so I have 2a plus b plus 3 for my final answer. And that is what I need for now.